All right, so today we are doing lesson 9.5, which is dealing with systems of equations. However, this time, instead of having an equation that's two linear lines, we're going to have a quadratic, and this is our standard form, and then also one linear line. So if we look at a graph of these, then we kind of have three different circumstances that could happen. So just like the number of x-intercepts, we can have them intersect up to 2 times, and then they may not intersect at all, so it might also just be 0 times. So if we do our quadratic, okay, we can just draw the parent function. Okay, so it looks kind of like this, whoops. And then let's actually reflect the parent function because it's not always going to be that. Okay, so we could draw our line that would intersect 2 times, okay, because it intersects once, twice. We could have it intersect 1 time at, there we go, okay, or we could have it intersect not at all. So we could still have 2 points of intersection, which I'm going to shorten to POI. We could have 1 point of intersection, and we could have 0 points of intersection. Okay, we're going to do 2 problems. The way that we solve this is the exact same as what we've done in the past, where we have substitution and elimination. So our first problem is going to be y equals x squared plus x minus 1. So that's our parabola. And I know that because it has a 2 as part of the exponent. And then we also have y equals negative 2x plus 3, and that's my line. Now, I don't have to graph these to solve them, but I could. And so if I did, then I would first look and say, okay, well, what is the overall direction and where do they hit the y-axis? So let's go ahead and color code. So our parabola will intersect at negative 1 because that's our y-intercept. And it's facing up because of the leading coefficient of 1. So, and if I did my my axis of symmetry, then we could say that that would be negative 1, over 2 times 1, so that's 2, so negative 1/2. So my axis of symmetry is here-ish. Okay, and so we're basically going like that, okay? And then my line has a y-intercept of positive 3 and a negative slope, so it's going down like that, okay? So we can see 1 point of intersection very clearly, and if the graphs kept going, then we would be able to see both points of intersection. So we are going to end up with 2 points of intersection here. So in order to solve using substitution, I'm going to plug this in for y because that's what y also equals. So we have negative 2x plus 3 equals x squared plus x minus 1. Now, because I have an x squared here, I'm going to have to either factor or use the quadratic formula or use completing the square. So I first want to see if I can factor because that's going to be fastest. So I'm going to add 2x to both sides, and I'm stacking these under so that the like terms are on top of each other. And minus 3, again, stacking like terms. So I get 0 equals x squared plus 3x minus 4. And I want to see if that can factor. So 1 times negative 4 is negative 4. And 2 numbers that multiply to that but add positive 3. Well, 1 and 4, they have a difference of 3. And if we make the 4 positive and the 1 negative, then we're good. Okay, so then this is going to be x minus 1 and x plus 4. And then using our zero product property, I can set them both equal to 0 and solve. If I add 1, then I get 1. And if I subtract 4, then I get negative 4. So those are not our x-intercepts, but it's the x-coordinate of this point right here, and where this point would be over here. So negative 1, 2, 3, 4, somewhere over there. So in order to actually solve the rest of it, we need our y values. So I'm going to use this equation right here. Y equals negative 2x plus 3. And I'm going to plug in x twice. So we'll start with 1. So when I plug in 1, I get negative 2 plus 3, which is 1. So that is one of my points of intersection. Now, if I do the same thing, but I plug in negative 4, negative 2 times negative 4 is 8, plus 3, that's 11. So my other point of intersection is negative 4, 11. Okay. Our next way is solving by elimination. So we have y equals x squared minus 3x minus 2. And y equals negative 3x minus 8. Okay, so when I'm doing elimination, I want to subtract the line from the parabola if this x squared is positive, just because it makes my life easier later when I go to factor. So I'm going to do y equals x squared minus 3x minus 2. That didn't change at all. And then I personally like to multiply by negative 1 to this whole thing, so that it becomes negative y equals positive 3x, but I'm going to stack that positive 3x under its like term and leave a gap because I don't have a squared term there. And then negative 8 times negative 1 is positive 8. All right, so then I can add and say y plus negative y, that goes to 0. That's good. We wanted that to eliminate. X squared plus nothing is x squared. Negative 3x plus 3x, that cancels as well. Negative 2 plus 8 is positive 6. And now I ask myself, can it factor? It cannot. So I'm going to, I don't want to do completing the square because I'm missing that middle term, right? So normally we have ax squared plus bx plus c. I only have my quadratic and my constant, so I could do quadratic formula, but I can also just solve by using square roots because I only have one term with x. So I'm going to subtract 6 from both sides, and we get negative 6 equals x squared. And then my next step would be to square root. But wait, we can't square root a negative, so this one is no solutions. Okay, so that means that if you look at the graph, let's go ahead and draw this real quick. So my line intersects down here at negative 8, okay? And it has a negative slope, and it's a steep negative slope, so it's going down like this. And then our parabola intersects at negative 2. And if we do the axis of symmetry of negative b over 2a, we get positive 3 over 2. So that's at 1.5. So right around here is our vertex. And it's opening up, so my vertex is a little bit lower. I don't know exactly where it is. I'm just guessing here. But my parabola is going this way. These two lines will never intersect because this will keep going, and this one will be a little bit steeper. And that confirms that we have no solution. So you can tell by looking at the graph how many solutions there are, and you can also tell by solving algebraically how many solutions there are. That's it for today. Let me know if you have questions when you come back to class.